Alright, what's up guys? Here's the Chapter 3 Mastery Review, kind of help video, whatever you want to call it. I will say I'm not going to go super in-depth to these problems. I will kind of push you in the right direction for where to find these answers beyond just in your math notes. They are either in the math notes packets or we've written them down during class. So first off, the associative and commutative properties. We had a nickname for the associative property. And the commutative property, we talked about the root word, right? And also the root word over here, associate, and the root word over here, commute. But if you don't remember those, or you didn't write them down, if you use your resources and go to Schoology, and in updates, because I can't yet figure out, well, I just haven't put the effort in, I guess, to get these into the materials page. But the updates page is where I'm able to just post things from my phone. And there was our board about the commutative property and the associative property. So then as we head into question 2, Stephen wants to make this problem easier and do it without a calculator. Emily suggested the commutative property. And based off what we saw on the last slide, I think we can figure out, I mean, really, I do not want to multiply 25 by 37. That's terrible. But 25 times 4 feels like it would be better. So if I could just get that 4 to be with the 25. All right, moving on, though, because I said I'm not going in depth to these things. Here in this first step, and now I'm going to start to color code. This is saying how did we go from step 1 to step 2. So what we noticed from step 1 to step 2 is the 2x was outside of any parentheses, and the 3x was in with the 19. Parentheses were used to group the 2x and the 3x because that addition can happen, whereas the 3x and the 19 couldn't. So these parentheses showing up here and also being taken away from here, that's what you want to talk about. Was it the associative property? Was it the commutative property? In the next step, they did the addition. So combining like terms, we can't do 2x plus 4, right? Because they're not like terms. So moving into step 3 to step 4, what happened? Well, the 4 was over here, moved over there. The 2x was here, moved over there. So numbers moved around, and that answer would go on this line, right? And the answer is not numbers moved around. It's either commutative or associative property. Or like simplify. Sometimes we use simplify, right? So 5x plus, these parentheses are new. What would that be? And that answer goes here. How many colors do I actually have? The answer for here is coming from step 6 to step 7. What happened? The 2x moved. And then down here on the last one, I think all that happened was 5x and 2x added together. I do have one more. We can do this purple. And that would be the fact that these joined up and made 7x. Right down here, number 4, some of us are still struggling with these diamond problems, which is all right because this is why we do them. It's good arithmetic practice. The top is the product, meaning it is the multiplication of these two numbers on this side. The bottom is the sum. Sorry, I should have said it's the solution or the answer to the multiplication. Bottom is sum. So when we add those numbers together. Now, the hint I'm going to give you here, or the push in the right direction, is that to multiply and get a negative number, one of these is going to have to be negative, and it doesn't really matter which one. So you might as well go ahead and put a negative, and then one of these has to be positive, right? Because if both are negative, a negative times a negative makes a positive, which we need negative 10, so one of these is going to be negative. That same rule is going to apply over here, but negative 0.5 needs to multiply by another negative to make a positive. So we should solve this multiplication, figure out, well, okay, now that we've done the signs, negative times negative will make a positive, we took care of that. Now we just really need to say half of something is 6. And again, this would be nicer if it was a fraction, in my opinion, because then I could just read it half of something. Really, this is 5/10, but we know it's also a half. Marcus, my man, you're essentially doing a diamond problem. So I'm just going to go ahead and draw this. but with a pencil so I can figure it out. Sum of negative 15, that would go on bottom. Product of 14, that would go on top. So again, we're trying to say two numbers are going to multiply and make a positive. So we know these either both have to be positive or could both be negative. And since this is negative, that tells us, yeah, both of these are going to be negative. All right, now Marcus said negative 2 and negative 7. That would work for the 14. It would not work for negative 15. So Marcus, I'm sorry, dude, you made a mistake. And the funny thing here is most of you are overthinking this and forgetting about the identity multiplier. And remember, identity kind of keeps numbers the same. So this isn't quite the identity since we'll be using a negative, but it's pretty close to identity. This was on your homework. Man, I had it written on the board. I think it was homework 3.1.2. I'm going to see if I can find that real fast. Good organization is key. Got it. So in the practice work from 3.1.2, terms are separated by addition or subtraction, because remember, subtraction is really just addition of a negative. Now be careful though, inside of parentheses, that's already grouped together. It's already associated. So that addition doesn't count if it's inside of parentheses. The addition outside of the parentheses does count and splits this up. So on your homework, you should have said that this had two terms. So likewise over here, this addition, and this addition, we might as well highlight those, right? Are going to break apart the terms. So the values, boom, 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 are your terms. And I'll just go ahead and tell you, come on guys, 1, 2, 3, 4. Hopefully everyone could have gotten there on their own. But we also need to write terms are separated by addition or subtraction, or you could just write addition since subtraction is pretty much the same. 7 is order of operations. By the way, C, you got to solve this, right? Go ahead and do the math, solve it, follow the order of operations. Again, order of operations, if we're going to kind of write out the PEMDAS thing, we're not going to write it as PEMDAS because we know when we get to multiply, divide, add, subtract, we're working left to right, doing them at the same time. A, I think would be a whole lot easier to make sure you do in the right order if we do this. But you should also put it on a piece of graph paper because we talked about it in class and it also says it here. In 2, yeah, parentheses first, then multiply, parentheses first. After the multiplication, we can then subtract. In C, this is division. Right, I tell you that. That's division. So, parentheses first, then multiplication and division, working left to right. And then, after we divide, we can then add. Guys, this is a big trap door. This division is going to happen before this addition. This division, we'll just go ahead and highlight that too. That division is going to happen before the addition. Hint, hint, nudge, nudge, wink, wink. In part D, in a fraction, these are grouped. The numerator is a group and the denominator is a group. So we could use the associative property to bring in some parentheses and help make our life easier that way. In 8, I think I told both classes that the main thing here is lining up decimals, but you're going to want to do this on graph paper. Trapdoors are subtraction, right? Addition is way easier than subtraction, especially with C. So I'll help you look at what C would look like. 7 minus 0.62. But now there's nothing above this. So we can always put zeros after a decimal point and they don't make a difference. But I can also use the giant 1 method of messing with both numbers as long as I undo it. So I can treat this like it's 700 and I can treat this like it's 62 if I make sure that I bring that decimal back 2 places at the end. So I can really do 700 minus 62, which really I could do 100 minus 62 because I know we're going to have to borrow out. So without having to actually do the long subtraction of borrowing and everything else, if you know that 62 to get to 100, right, you don't really have to do subtraction if you think about the addition. How far is 62 from 100? 38, right? So this is going to be 6.38. Guys, 9, 10, and 11, we're all keep, change, flip problems. It's you're taking the quantity that you have, splitting it up into the amounts that you want. So if I bought 6 pounds of turkey, and I'm going to split it up into 3/8 pound patties, guys, this is fraction divided by fraction. You might say this is not a fraction. Oh, yes, it is, because we can make any number a fraction by putting it over, yeah, that's right, over a 1. I hope you said that out loud on your end. And then I'm not doing 10 and 11 for you. You can come get help if you need. In 12, again, you're going to do this on graph paper so that you have space and I can actually read it, but just to help you guys get set up, what we would probably be doing to help that little sister is starting by drawing the generic rectangle, since that's in the directions. And then in our math notes, it told us to split our generic rectangle, or sorry, split our value using the generic rectangle. And then we're going to multiply, kind of like playing Battleship. So I'll do a couple of these with you. 3 times 6 here would be 18. I'm going to change colors for the inside of this. And then, again, the giant 1 method of if I do the same thing to both numbers, I can treat this like 2 and I can treat this like 4. As long as I realize there's 2 decimal places needed in the answer. So although 2 times 4 is only 8, there are 2 decimal places needed in the answer. So this ends up being 0.08. Be careful with that. I'm going to leave these 2 boxes for you to do on your own, and then we add up the whole thing to get our final sum. All right, guys, if you need more help, come get help from me because you're about to walk into my classroom for foundations. So I will see you later.